This video, we're going to talk about the conic section called an ellipse. An ellipse is egg-shaped. I have kind of a hard time drawing an oval or an egg shape. Um, hey, there we go. The whiteboard knows how to do that for me. So it's not a circle, right? It's elongated along one of its axes. And so the long axis there is called the major axis. And the small axis here is called the minor axis. And I'm going to write my equation of my ellipse, my general form of it, so that the major axis is A, the minor axis is B, and that the major axis is in the X direction, since that's how I've drawn my ellipse there. So it's going to be in the form of X minus H squared over A squared plus Y minus K squared over B squared is equal to 1. It's very similar to the equation for a circle, if you remember that from geometry or algebra 2, whenever you did that, because if A equals B equals what we're going to call R, the radius of the circle, then we would have X minus H squared over R squared plus Y minus K squared over R squared would be X minus H squared plus Y minus K squared over R squared, and X minus H squared plus Y minus K squared equals R squared. This is the equation of a circle. This is the equation of an ellipse. We're going to use ellipses to talk about things like planetary motion, Kepler's laws, things like that. The idea here is that I have two objects that are pulling on two points here that are equidistant from my center along my major axis that are my foci. And it is like they are both pulling on my object. So whichever one it's closest to is pulling more. But we get, if there's only one thing pulling on my object, I'm trying to draw a circle there, then we get a perfect circle. But if we have two gravitational forces, let's say, pulling on my object, then I'm going to get an ellipse like that. More on that later when we get to application problems. Let's just right now talk about using my equations here to find my center, foci, and vertices of the ellipse. So x squared over 64 plus y squared over 9 equals 1. Because 64 is the bigger number, it's a squared. I always want a and b to be positive numbers because they're distances. But I can call that plus or minus 8 if I want to, but it's a distance, it's 8. B squared is 9, so b is 3. So this tells me that because my bigger number was with x, that my ellipse is horizontal, like that. I'm going to have a center that's at 0, 0 because I'm not subtracting anything from x or y. I'm going to have an endpoint over here at 8, 0, and another one over here at -8, 0. I've got a point up here at 0, 3, another point down here at 0, -3. And I have not told you the equation yet for finding the foci, but it is similar to the Pythagorean theorem, but it's not a plus, it's a minus. So it's big a squared minus b squared equals c squared. And so c, which is going to be my distance to my focus, is going to be the square root of a squared minus b squared. Well, that's the square root of 64 minus 9. So c is root 55, which doesn't simplify anymore, but my foci are going to be at 0, negative root 55, and second focus is at 0, positive root. Sorry, said that backwards. We're going in the x direction here. So negative root 55, 0. That's what I meant to say. And positive root 55, 0, because my foci lie along my major axis. So they're over here somewhere, past 7. They're real close, in this case, out over here to my ends at root 55, 0, and at negative root 55, 0. Let's try this next problem here. X squared over 9 plus y squared over 49 is equal to 1. So this one has a major axis in the y direction since the bigger number is under y. So it's like that. My vertex, or my center, excuse me, is at 0, 0 again. And we have a distance of 3 here on my minor axis, and a distance of 7 here on my major axis. And then we're going to find 49 minus 9 is going to be root 40 is 2 root 10. And that's going to be in the y direction. So now I have y values for my foci, like that. And those are 10s, not 16s. 10 and 10. There you go. Now we've got 9x squared plus 64y squared equals 576. So we're going to have to divide by that 576 for everything. To get a 1 on this side to meet my form. 9 goes into 57 6 times, with 3 left over. That gives me 64, so that tells me that the other factor down here is going to be 9. And, oh, look at that. That's my same equation that I had for number 1. I don't have a different problem at all. So this is my horizontal parabola again, with my center at 0, 0. And my vertices are along the major axis. If I didn't say that before, I give the additional points that are on the minor axis as well, just because it's not hard to do that. But when the teacher talks about vertices, they mean the endpoints of the major axis there. And again, we found the foci already, but let's find it again. And we'll get it right this time that these are in the x direction. There we go. And I assume that this one is going to work out very similar to number 2, but it might be different. So we're going to divide everything by 144. This is going to be x squared over 9 plus y squared over 16 is equal to 1. So we have a vertical ellipse there, still centered at 0, 0. And it's 3, 0, and -3, 0 on the minor axis, and 0, 4, and 0, -4 on the major axis. And we're going to have c is the square root of 16 minus 9 is the square root of 7. We're going to be in the y direction here, so our foci are going to be 0, -√7, and 0, +√7. These are very basic problems that were centered at the origin. It's not always going to be that way. We also may have additional terms in here that have x or y that are going to cause us to have to complete the square. So we'll do some of those more advanced problems as we get later on through this section. But these first few problems were just kind of to warm up and to compare the ellipse to the circle and just give you the very basic general form where it was centered at 0, 0. So don't look at this and think that it's always going to be quite this easy. We are going to come back to using that completing the square skill that we started to use a long time ago in chapter 2 of the textbook, back in Math 161, Pre-Calculus Part 1. All right. See you for the next video.